All right, hello everybody. As I mentioned in the email this morning, we won't have in-person lecture. I've got a sick kid today, so I've got to do a little bit of taking care of him. So I won't be able to make it to lecture. That said, I've got two videos that I want you to watch today that will cover some very important concepts. And just know that I'm not going to recover these videos in future lectures. We'll kind of touch on these things, but I really expect you to watch these lectures and kind of learn the content of these videos. We're going to start off with one short video, and this is to kind of pick up where we left off a couple days ago, looking at this kind of stretch of DNA that codes for a protein. Okay, this is kind of our review of the genetic code, and so we have this kind of long stretch of DNA here. I actually added back, I missed this on Monday, so I added this back in, but this stretch of DNA right here ends up coding for this protein right here, methionine, proline, tryptophan, arginine, alanine, glycine, serine, then a stop codon. So we've got this sort of reading frame starting with this start codon going all the way through to this stop codon. Okay, that's how the genetic code works, 3 nucleotides per codon, right? And so what I want to do now is use this to springboard into thinking about the consequences of mutations in a stretch of DNA and how that affects the coding of a protein, okay? So I outlined 4 different mutations, theoretical mutations that can occur, and what I want you to do on your own is to work out what is the consequence of each of these mutations on the protein that's being coded by this stretch of DNA, right? So we got our first mutation is right here, so it's just trying to figure out what happens if you change this C right here to a G, okay? So it's a simple C to G switch. This is our first mutation. The second one is right here. It's to consider what happens if this G right here is changed to an A. Okay? The third mutation I want you to consider is right over here in this GGG triplet. What happens if this G right here is changed to an A? What is the consequence on the protein? And the last one then is to consider what happens if we actually insert an A right into here. Okay? So you can think of all of these mutations as really forms of SNPs, single nucleotide polymorphisms. And so what I want you to do is go through, kind of, again, review how this DNA codes for this protein and figure out how these mutations individually will affect the protein that's being coded. As you do this, I've got 4 terms that I want you to be able to learn and use in this one, okay? Silent mutation, frameshift mutation, nonsense mutation, and missense mutation. So these are all terms that can really help us describe accurately what's happening to the protein that's being coded as a result of a mutation in the DNA sequence, okay? As you do this, it's going to be helpful to have access to a codon table. I recommend you use the codon table. Figure 15.4 in OpenStax Biology has the codon table that I showed you in lecture on Monday. Right, so we may kind of touch back on this one in lecture on Friday, but I really kind of expect you to be able to do this and to be able to understand these terms. Okay? Next video is coming up pretty soon. Thanks.